Okay, great. So we're going to do a workshop tonight all about some fundamentals of programming that I hope you're going to get a lot out of. So first of all, let me know in chat if you can see my screen where it's got my smiling face. Grab chat. All right. Thank you, thank you, thank you. Okay, good. So this is me. I don't know why my picture disappeared. That's probably for the best, right? So I've been a developer for a long time. While there's no formal rankings for software developers, you can call me a senior level developer. I've done a fair bit in my career. For those of you who have joined us for a few classes, you already know this. I'm a military veteran. I was in the U.S. Navy for 6 years, way back in the day. I was a nuclear reactor operator. That's awesome, Rob. Thank you. I was a nuclear reactor operator, an electronics technician, and thankfully, I got picked up to be an instructor at a certain point in my career. Something I hadn't done before, but I found my passion when I was given an opportunity to be able to teach people about technology. And over the years, I've worked really hard to get good at that. I'm also the co-founder of the Tech Academy. That's the organization that puts these free classes on. More about that later. Oh, and of course, now my picture appears. That's great. All right, so we do have an assistant in the chat. Regina's monitoring the chat, and she's there to make sure that chat goes well and to answer any of your questions. We do have a Q&A towards the end. If you want to, use the chat as much as you like. She's awesome. Just be nice. If you're not nice, she'll get rid of you, but hasn't been a problem because we have awesome people that show up for these classes. So just to go ahead and test this, I'm going to watch chat right now. If y'all could do me a favor and just throw into chat, where are you joining us from? If you haven't put that in chat already, put in here, where are you joining us from? Oh, good. Quenga's calling in from Bhutan. I think you were there last class. That's fantastic. New York. Toronto. We get a lot of people coming in from Toronto, Canada. Montreal. That's fantastic. Excellent. Wisconsin. Love it. Okay, good. So we've got a really good representation here. All right. Quick comment about chat. The chat only goes to the hosts and panelists. We don't have it open up for everybody to chat back and forth. But we do see everything you put in there. So if you have questions for us, it's part of the reason we do it that way is to make sure that nothing gets lost and we answer all of your questions. Wow, Alicia, you're joining us from Belgium. That's fantastic. I'm really glad to have you here. Wonderful. All right. So here's the agenda for the day. We'll have a short explanation of the Tech Academy, who we are, what we're all about. And then we're going to do our workshop. Super excited about it. We'll have time for, I think we'll have time for a Q&A session on this one, answer any questions you have. And if you don't, we have a way for you to send the questions in to us. Then we're going to go over some information about our boot camps, who we are, what we do. We have a free gift for you at the end, so please stick around for that. The whole class is about an hour to an hour and a half, and we aim to make them as helpful as possible. And more precisely, what we're trying to do here is do two things. One is to show you how we teach. There's a lot of different approaches to learning a technical subject. And we just want to share ours so you can see whether or not it fits with you and the way you learn and with your purposes and goals as they relate to technology. And the other reason we do these is because we have a very strong mission to be the bridge between society and technology. We are inundated with technology. We cannot escape it even if we wanted to. And so anything we can do to make it easier for people to be in control of the technology that they have to use all the time, rather than be the effect of that technology, we love doing things like that. So who are you? Who are we? Well, we're the Tech Academy. We are a coding boot camp. We've been around for 10 years, which is awesome. And we've been offering thorough, budget-friendly, flexible, and trusted coding boot camps throughout the entire period. One thing we want to point out is that our certifications, our programs are very beginner-friendly. They're cost-effective, and they're self-paced More on that later. And they can all be done online. We do have our campus in Portland, Oregon, but they can all be done online. And our programs are tailored for beginners that have no prior technical or coding knowledge, which is really, really nice. We also teach in-demand skills, things that the tech industry needs now. And we're endorsed by stellar online reviews. And we designed the way we deliver our training to fit around your personal schedule. It's really flexible, as we'll talk about later on. And we want to prepare you for a technology career with a really well-rounded toolkit. More on that later on. Our boot camps are priced really affordably. The average cost of boot camps in the country, in America, is $13,500. Ours are under that national average, and we can have boot camps that start as low as $5,300. One thing I read every time, because it's so important, is what our mission statement is. Why do we even do what we do? The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. That's what we're all about. Our product is you working in tech. All right, so a couple things about class expectations, what this class is and isn't. You're going to learn a lot of simple definitions for technical terms. That's actually really, really important. One of the challenges I face, even as an experienced engineer, whenever I'm trying to study some new subject, is that the definitions of the terms and symbols involved in that new subject very often don't have adequate, simple, clear explanations or definitions. It's a real problem in technology education. And so that's one of the things that we've sought to solve. And we're going to give you a lot of those today and explain some of these complex technical terms in very simple, easy to understand ways. We use plain English to explain these things. In this class, there's no coding. We do have free coding classes. You can find those on our Meetup pages. We'll have links for that later on. This class doesn't have any actual coding. You can go to Meetup, though, and register for that next free coding class. They're a lot of fun. Regina, if you could paste that link to the next free class in chat, that would be awesome. Excellent. There's that link. I'll wait a minute if people want to click on that to see our next classes. Please do register for those free coding classes. If you want to find out whether or not coding and technology is for you, whether you enjoy the actual experience, there's no better way to do it than do one of those classes. Awesome. Thank you, Jeremy. Okay. So let's go ahead and end off on this part of it, and I will stop sharing for a moment, set up my slide deck. All right, so what we're going to talk about tonight is what is programming. Now, we're going to start actually, even before programs, we're going to start with the things the programs go on. They go onto a computer, duh. Well, what is the purpose of a computer? This part is actually really important, and I'll explain why after I tell you what the purpose is. The purpose of a computer is to take in data, to process or work with that data, and then to send that data on somewhere else. That's all this machine is for. These machines that are super complex, they cost lots of money, and they come in all different shapes and sizes, whether it's your watch, I've got my Apple Watch here, whether it's your mobile phone, whether it's your desktop, your laptop, like the only purpose they have is to take in some data, process it, and send it on somewhere else. Now, they can take it in from a lot of different places. User input, like when you're clicking around on a website or typing on your keyboard or moving your mouse. They can take in data from another computer. They can take in data from physical machines. But that's the first thing they do is they take in data. The second thing they do is they quote unquote process it. That just means to work with the data. Think of something as simple as alphabetizing a list of students, or something as complex as calculating complex and precise insurance probabilities for, say, an auto insurance company, right? But they're going to process that data, they'll work with it. And then they're going to send it on somewhere. And again, that can be to a human being, like something will appear on your screen, or it can be to another machine. There's another computer that needs that now processed data, and so your computer sends it on. And I said that this is really important. I want to give a little bit of context why. As a technology worker, you're very often going to be working with what appear at first glance to be quite complex systems, sets of, say, 5 or 10 different computer programs that all interrelate and work together in some way, or combinations of physical hardware like electromechanical devices or robots that, send data into a computer program or multiple computer programs. Like, the systems can look really complex, and they are complex. But the fact is, if you look at any complex system with this particular piece of data in mind, you'll start to find the points in the system where this exact thing occurs. Where does data come in? Where does it come from? What does it go into? What kind of device? What kind of machine? What kind of computer? What does that computer do with that data? And then where does the data get sent on to? So this is one of those fundamentals of computing that actually relates to everything you'll do later on as an engineer. And so it's pretty important to understand this is the purpose of a computer. Now, in order to get it to do those three things, to take in data, to process it, and then to send it on, we have to tell the computer exactly what to do. This is an inert machine. It's just a piece of of metal and moving parts and wires, and some electricity goes into it, and it will not do anything unless it's told exactly what to do. And the way you do that is by creating programs. A program is a series of instructions that a computer can understand and operate off of that direct the operation of the computer. Directed to do what? Well, to take in data, process it, or send it on. So that's a program. To get a program into a computer, you go through a process of what's called installing. I want to talk about this a little bit. We've all done it, but there's aspects of it that you may not have really thought about when you're a consumer of programs, but that you do have to think about when you're a creator of programs. Let's just use Windows as an example. What I'm going to talk about applies also to operating systems like Mac operating system. It's called Mac OS. It applies to operating systems like Linux. It applies to the operating systems that are on your mobile devices. This applies to all of them. The operating system is the one big primary computer program on almost every computer. And it's there to do a lot of things, but you can kind of summarize it as, one, to take care of a lot of background things that need to be done. Things like constantly checking to see whether data is coming into the computer. Things like keeping track of all the files and folders on that computer and allowing other programs to access those files and folders. These types of things. But one of the most important functions of this thing called an operating system, like Windows, is, even though it is itself a computer program, it also has functionality that lets the owner of the computer install other programs. And again, I know this seems like a simple thing, but I'm asking you to look at it from a different point of view because you're considering becoming the creator of programs. And it's helpful to know that when you make your program, it will need to go through a process where you add it to a computer, and the computer gets set up so that when that program that you created is needed, it will actually be able to run. And that's what installation is. So we talk about these programs and that you're going to quote unquote write a program. Well, you need to write them in some sort of text format. There's some sort of set of words and symbols that can become instructions your computer understands, so it'll do what you tell it to. And these sets of words and symbols, we call them programming languages. There are a lot of them. Thousands, actually. some of the most popular languages, I'm sure you've probably heard of most or all of these. The first one I want to talk about is JavaScript, very popular programming language. Now, when JavaScript came around in about 1995, it was built to solve one specific problem. And for about 15 years, that's all we used it for in the industry. And that problem was the web was brand new. And at the beginning, all it was collections of web pages that were static. It was just words and pictures, and you couldn't interact with the page at all. You couldn't, for example, scroll over an image and it would suddenly pop up much larger. You couldn't, for example, have a calendar on the page where you could click on it and it would allow you to set an appointment with a business. None of that was available at the beginning of the web. You could almost look at those early websites as online catalogs. Like you could send someone a paper catalog, or you could take all that content and throw it up into a bunch of web pages and people could browse through it. They were called static web pages. So we developed JavaScript as a way to make it so that those formerly static pages could have some dynamic behavior. They could present different data based on what user was viewing the page, for example. They could do things like if you roll over an image, now it expands and you can see it in more detail. That and thousands of other dynamic capabilities were all capable of being added to a formerly static web page because of this cool programming language called JavaScript. Beginning around 14 or 15 years ago, the technology was developed to have JavaScript, be used to create programs that weren't just going to run on a website, but instead computer programs that would run on computers outside of your web browser. And it made them a lot more versatile. These programs that you created could do things a lot more complex than just let someone interact with a web page. So JavaScript in that, in the last 14 or 15 years has become extremely popular for that reason. It's very well maintained. It's relatively easy to learn, but it's also very powerful. So that's JavaScript. Another language that many of you probably heard of is Python. This is, a symbol of, two different snakes. Python is a snake, right? Python has been around since the late 80s and is also very easy to learn, much like JavaScript is, and has a lot of the same sort of functionality as JavaScript. It works a little differently. Pretty easy to learn, but very, very powerful. You can write extremely complex applications, computer programs that will let you run all of the different aspects of a business, from marketing to sales to inventory to accounting, various reporting, all this stuff that can all be done with Python. Then there's a language called C#. This was created around 25 years ago by Microsoft as an effort to create a language that could be used for an approach they called rapid application development. Languages prior to C# often had a really steep learning curve, and you needed to know a tremendous amount about what goes on down inside the operating system in order to create programs really easily. It was kind of tough. You could do it. Lots of people made computer programs before this that were pretty powerful, but C# gave you a tool where you didn't need to know all that stuff and you could still write extremely useful programs. And in the 25 years since, C# has grown extremely popular. Right around the same time, or a couple years before, the programming language Java came about. And Java, very similar to C#, can be used to create almost any computer program you would want. Lots of computer programs that we're used to using, we know that there's a user interface. It's some sort of a form or some kind of a screen that we as a user will interact with. And C# and all these languages can be used to create programs like that. One of the areas where both C# and Java are really powerful is there are computer programs you might need to make that don't have a user interface. Let me explain that. If we go back to the first slide I showed, where we talk about the purpose of a computer, I said that it's there to take in data, process it, and send it on. And one of the scenarios I described is that the data might come from a computer, not from a user input. Data might come into your computer from another computer. And your computer will work with that data, and it might send it on to another computer. No human is required to interact with that data. in that kind of a scenario. And there are actually lots of technology like problems that you'll need to solve where this is the case. C# and Java are very good at creating those types of programs in addition to programs that do in fact have a user interface. So again, I said there are thousands and thousands of programming languages. These are amongst the 4 most popular. We offer at the Tech Academy boot camps that specialize in each one of these languages and more. Now you might ask, why are there different programming languages? And there are in fact thousands of them. And the reason has to do with what they are intended to do. What types of programs are they intended to create? You'll see, for example, when we look at JavaScript in the top left there, it was designed to solve one specific problem when it came about. It was not what we'd call a general purpose programming language. It was a specific narrow purpose of, hey, we got these cool web pages. They're starting to get kind of popular. More and more people are going to the net, the web. All the cool kids are going there, right? Well, we need some language that we can write little programs in that will make those web pages interactive. That was the only reason they made JavaScript to begin with. Now it's expanded over the years, but you can see why they needed to make a language for that one specific use case. But then you look at C# and Java, they were developed with a very broad mandate, a broad set of types of programs that you might want to create. So it just depends, again, on what's the use case behind the language. Even today, every year, new languages are created, and sometimes they get really popular and receive a lot of like uptake in the technology industry, and then sometimes they just disappear. 2 or 3 years later, it's like you never even heard of them. What we teach are what's in demand in the industry, and these 4 languages, they aren't going anywhere, which is really, really cool. All right, so we've talked about the language. Let's talk about what coding is. Coding and code. First, let's talk about code. Code is the instructions themselves. I said that a program is a set of instructions you're going to put into a computer to make it do stuff. We talked about the fact that the things you're going to make it do break down ultimately to only 3 types of activities: taking in data, processing the data, or sending the data on somewhere else. So code is the actual written instructions. You're going to see some examples of these later on in tonight's workshop. Therefore, we can make a verb out of it. Coding. Coding is the action of writing those instructions. This is one of the primary activities of a computer programmer, is to write these instructions out. And when we do that, we say we're coding. There's lots of terms that are the same, that are interchangeable. Programming, developing, those all mean coding or writing down the instructions. Now, one little side note here that may surprise you if you're considering looking at the tech industry. There's a common misconception that as a computer programmer, you spend most of your day coding. Nothing could be farther from the truth. To be sure, there might be periods, brief periods of intensive coding where you might spend 3, 4, 5 hours coding. More often than not, though, you'll only spend about 25, 30% of your time in any given week or month actually writing code. There's a lot of reasons why, and we do presentations on a day in the life of a developer and what it's like to actually do these technology jobs. But the short version of it is that making software is a collaborative team activity. And in order to design really, really good software, you need to communicate with people a lot. Communicate with the end users. Communicate with the business, because there's a business reason usually why you're making this piece of software. Communicate with your senior technologists about what's the right design for this piece of software or this computer program we're going to make, right? Communicate with the people that are going to test the software to make sure that they have a very clear understanding of what it's supposed to do, so they can test whether or not it does what you said it should do, and so on and so forth. So there's a lot of communication and collaboration that happens. You'll probably, like I said, only spend about 25, 30% of your time actually sitting down and writing the code. And so one more aside, that means you don't need to be a fast typist to be a computer programmer. We keep hearing this over and over again throughout the years. I don't type very fast. I can never be a programmer. Let me tell you, I don't type very fast. It ain't pretty, but I don't need to. No programmer does. It isn't the speed of how quickly you type. It's knowing what to put down as an instruction. Much more important than how fast you type it out. All right. So let's talk about the action programming of a computer. I already kind of, touched on this, but it's really critical. Computers only ever do what we tell them, which means when you're writing these programs, when you're entering in these instructions, if you have not provided a specific set of things to do for a given situation that could occur inside your program, then when that situation occurs inside your program, the computer won't do anything. It can't just figure it out. It can't assume what the logical action would be and take it. If you didn't tell it exactly what to do, then it won't do anything. And sometimes it'll just close your program and your program breaks. Now, when you learn how to create programs intelligently and handle these things, that's an easily solvable thing. But I speak about it more because I'm trying to illustrate one of the factors in how to think like an engineer, how to think like a computer programmer. Computers do not handle ambiguity. They require explicit instruction. If you're going to give them options, you have to define the exact criteria for when they do option A and when they do option B, and so on and so forth. And they are ultimately an electromechanical machine that can only, like I said, do what it's told to do. How does this affect the way engineers and programmers might think? Well, there's a very common pattern of thinking or viewpoint about business and life that a lot of engineers have, and can be very cut and dry. Yes, no, true, false. It does not handle ambiguity. One of the things that makes computer programming so much fun, though, is that we are creating these computer programs to help real people, human beings, solve real human problems. And humans have lots of ambiguity. They can often do things you don't predict. And it's this balance between the logical, strict nature of the computer and how you have to program it, and the very human factors of the people that are going to use those tools we create, that makes it so fun and challenging to create good software. Another note about programming a computer. Despite media articles to the contrary, computers are not alive and they cannot think. There's no spark of life inside this thing. It's just a machine. And there won't ever be. So, when you see all these modern tools about artificial intelligence and really complex, powerful computers, sometimes, probably just to get clicks, it can be represented as, oh, computers are being super intelligent. Oh, we're going to reach the point where they're smarter than human beings. The fact is, it's a machine that will never actually have a single ounce of true intelligence in it. Now, that doesn't mean we can't create programs that very closely emulate the way people think. We did a presentation about a week ago on artificial intelligence. It's awesome. You can find it on our YouTube channel, where we go into this in a lot more depth. But I just want to stress this because it is a common misconception. Computers can't think. And finally, I want to talk about the purpose of programs. Programs take that high-level purpose that I talked about for a computer. They take that purpose of taking in data, processing it, and sending on, and they constrain it down inside a specific type of work that needs to be done. So you might have a type of work that needs to be done, for example, involving the very real and necessary activity of managing inventory for a physical goods company. That's a specific purpose. Contrast that with, you might have the need to manage predictions for stock changes on the stock exchange, financial prediction. Those are two totally separate domains of human activity. And so when you're writing a program, you start from, what is the human problem I am trying to solve? What is the domain of activity that is going to help people be more efficient in, help them accomplish their goals in? And so the purpose of a program is to make humans more efficient, more capable, or happier. That's what it's for. They're there to serve people. And you make programs that do that in a specific domain or area. of operation. All right. Now, those of you who have attended a few of my classes know exactly what's coming. What we're going to present on this what we're going to present on this slide is some of the most important data you will ever learn about programming. Period. Full stop. Every single computer program that you have ever used or that you may ever create in the future, if you go into technology, every program makes use in one way or another of 5 specific elements, and only 5. So knowing these gives you a tremendously firm bedrock foundation of understanding to figure out what's going on with almost any computer program that you might want to create or that you might inherit and be tasked with maintaining or improving. So what are those 5 elements? Every program needs an entrance point. We talked about the fact that programs are sets of instructions you're going to have to put into a computer to tell it what to do. Well, every program needs a place to start. What's the first instruction? What do I do to start this whole task or function that you made the program to do? I've talked at length about this, so I'm not going to go too deep into it. But one of the primary reasons that's important is when you start working on a huge complex program that you didn't make, one of the most valuable things you can do is to start looking through the instructions as close as possible to the entrance point and then start tracing through what does this program do. It helps you follow the logic of what the instructions are there for. And so knowing how to find that entrance point is a really valuable tool as an engineer. The second fundamental element of any computer program is what are called variables. Variables are places inside your computer that store data that can change over time. Let me be more precise. A computer program obviously works with data. We said the purpose of a computer is to take in data, process it in some manner, and send it on. Well, you have to keep that data somewhere. To get all nerdy about it, inside your computer is a physical device called memory, and it stores data. It's pretty cool stuff. Well, each of those places you can store data has a name. You can name and identify the exact spot, and there's billions of them in any modern computer. It has billions of little locations you can store data. Computer programs need to keep track of data that they store in those devices, data that can change while the computer program is running. Let me give you an example to kind of illustrate this. If you're making a computer program to keep track of, again, say the inventory for your retail product company, you need to be able to keep track of the amount of inventory you have on hand at any moment in time for any particular product. I'm sure that probably makes sense to you. For any given product, this exact bicycle model in this exact color, for example, you want to know how many you have on hand at any one time in your warehouse. You would store that information in a variable. Why a variable? Because you could be working throughout the day using this program, and all of a sudden you get a new shipment in, and your inventory level changes. And your computer program has to have a mechanism to be updated to reflect the new current data. If you were to think about a computer program where you weren't able to have it deal with changing data, you can see it would be quite restricted in its usefulness. So one of the 5 elements of a program that's got to be there is variables. Next element of the 5, control and branching instructions. These are elements in the computer language where you can write an instruction where a decision has to be made. If the inventory level reaches too low of a point, then order more product. As an example, you've got now that's something we would of course do as human beings if we were going through the warehouse and we saw we only had 5 of these particular bicycles left and we sell a lot of them. We would manually write down an order form and put it in the mail, send it off to the supplier and say, please send us more of this model. We want to make that process faster and more efficient. And so we turn it into a computer program, but we've got to be able to have something that can make decisions for us. In computer programs, those are called control and branching instructions. Let me explain the 2 different parts of that. Control means you're going to control the direction of instruction of the computer. You can control what it does. More precisely, you have more than one available thing it could do, and you're going to control which of those things it's going to do. If inventory level is equal to or above a certain point, don't order any more product. Just go on to your next thing you're going to do. However, if inventory level is below a certain point, then do order more product and then go on to the next thing you're going to do. You can kind of see how this would work in English, right? We need computer programs to be able to make those decisions for us. Let's look at this second part of it, which is called branching. Each of those two or more possible, quote unquote, things that could be done is called a branch. Think about traveling up a tree. Branches go off to right and left and all around. Each one of those, if you're going to compare that to a computer program, is a possible action that could be taken if a certain criteria is met. Every computer program makes use of this mechanism, which means every computer programming language has a way to write instructions like this. The fourth element, which is unbelievably powerful, is a concept called subprograms. You can think of them as programs within programs. Let's say there is a specific set of, say, 5 or 6 instructions that you find yourself repeating over and over again as your program is used. For example, every single time you've got a computer program where you are managing all of the classes at a large college. And every time you switch from looking at one class delivered by one instructor or professor to another class viewed by another professor, you have this exact same thing you need to do, which is you need to reach out to a database and find every student who's currently enrolled for that class and display them on the screen. That set of actions you're going to take will be the same exact thing every single time you switch to looking at a new class. So instead of writing down that set of steps over and over again in your program, you can take that set of instructions and put them into one little box, if you will, called a subprogram that contains those instructions. And then every time you need that exact series of instructions to happen, all you have to do is ask for that subprogram to be performed. And when it's done, to come back where you were when you asked for it to be performed. There's a lot of benefits to that, not the least of which is it makes it easier to maintain your program and to write your program. You're not typing the same thing over and over again. But the other real big advantage is if you need to change that set of instructions that's in the subprogram, you only need to change it in one place. And that change gets reflected into every place that subprogram ever gets used, which is really powerful. The final element of any computer program is an exit point. Whether it's specifically stated in your program or not, we need a way to inform the operating system that your program is no longer running. Remember earlier we talked about one of the primary things that an operating system like Windows or Mac OS or Linux gives us is the ability to install computer programs. Great, fine. Well, when they're installed, they're not doing anything. They're just sitting there, occupying no resources of the computer they're on. It's just a program that could run if you ask it to. But then you start the program. When you start up a computer program, your operating system is there to help your computer program with a lot of things it might need. For example, managing all this data that's stored inside the memory of the computer, letting your computer program make use of some of the memory and make sure that no other program that's running on the computer can touch the data for your program. That would be a pretty important thing. You wouldn't want to have two programs running simultaneously and one of them can reach into memory and change the data for your program. That would be really unsafe. So when we're running a program and your operating system is taking care of a bunch of stuff under the hood for that program, we need a way to tell the operating system, hey, we turned off that program. You no longer need to be taking care of it and reserving resources for it. So your program needs an exit point. So if you look at these 5 things, any computer program you'll ever use makes use of them. They aren't necessarily in order in the exact order you would add them into a program. That's not what we're illustrating. We're just saying that if you look at all of the instructions in a program, they ultimately break down to one of these 5 things, and that's all. And there ain't no more. So if you know these really, really well, it makes analyzing and building computer programs a lot easier to confront. All right. Now I'm going to show you an example program. Now, this program is not written in an actual computer language. I want to stress that before we start breaking into it, okay? You could call this pseudocode. P-S-E-U-D-O. Pseudo, it means false, fake, not real. Pseudocode is a way of writing down what your program would look like if you were to write it in a real programming language. It helps you kind of work out the logic. So let's look at the logic here. We would have a starting point, a point where the program begins. We have some variables. We have a variable called secret number, and it's given a value of 5. We have another variable called user guess. We set it to 0. Now, even from these first 2 lines, you can kind of get a little bit of a sense of what we might be building here. This is a computer program where people have to guess a number. Pretty simple. So we have a starting point. We have some variables. Now let's create a subprogram for getting a guess from the user. Notice the way we've formatted the text here for readability. It shows you where the subprogram begins. It says subprogram get user guess. And where the subprogram ends, it says end subprogram. All the instructions in between there are this quote unquote program within a program. They are the subprogram. They are those instructions that we want to have run on demand. So an important thing to know is when you've created one of these subprograms, it doesn't just automatically get performed. Somewhere else in your computer program, you have to ask for that subprogram to run. The language we use in computer programming is if you want that subprogram to be used, you have to quote unquote call the subprogram. We say we are calling, in this case, the get user guess subprogram. So you can see what it does inside. It'll put something on the screen that says, hey, guess a number between 1 and 10. It'll take that and it will take the variable user guess that we created a little bit earlier, and whatever the person entered, any number between 1 and 10, now that number they entered becomes the new value for the variable called user guess. So this is where we actually start doing some work. I'm going to explain this in a little bit of detail here. You're seeing, again, this is pretty much like a real program. In a moment, you're going to see it in actual real language. But right now, we're dealing with this pseudocode thing. We're saying, look at that first line where it says, while user guess is not equal to secret number. Don't go any farther. Let's just talk about that. We talked about this idea of control and branching statements. This is a control statement. It says, please check a certain condition. And based on whether that condition is true or false, do something. Here, the condition is, have they guessed the number? Is the variable called user guess now equal to the secret number that they're trying to guess? As long as it is not equal, as long as they have not guessed the number, we will do everything inside this while construct. And you can see from the way we formatted it, when the while construct ends, it's about 7 lines down. It says end while. So what this means is we're controlling what the computer does by saying, as long as the person has not guessed the number correctly, keep doing everything inside this section. What do we do inside that section? Well, let's look at the second line there. We call this subprogram called user guess. No, sorry, get user guess. And so when we do that, all of a sudden, the instructions inside that get user guess subprogram, they are right up here, those get executed. We'll display something, we'll get their data, and we will then use what they entered and change the value of the user guess. Then we're going to check, are they equal? Is this variable called user guess? Does it have a value? this equal to the value of this variable secret number? If so, then we're going to say, hey, good job, you guessed the right number. The else means if not, if they aren't equal, what do? Well, we display wrong guess, try again. And then we say we're done checking this if. Now, this whole series gets repeated over and over again because every time we end here with the end if, the computer checks, hey, is user guess equal or not equal to secret number? And again, as long as they're not equal, because the person hasn't guessed the number, we will keep on doing everything inside this while area. So that's an example of a program. Admittedly, it's a relatively simple program, but that's not the point. We just want to illustrate these 5 elements. Now, the 5th one, an exit point, some computer languages specifically require you to have an instruction that says exit the program. Most do not. Most programs interact with the operating system so well that when they're done running, the operating system knows it. But some languages, every once in a while, you learn this when you're learning different programming languages, they'll specifically require you to lay out when do I end off. What we know is as soon as user guess is equal to secret number, we will end this while section. There's nothing after it. And so the operating system knows we're done. So that is an example of a program utilizing all these elements. What I want to do now is I want to show you that program actually written in a real programming language, JavaScript. So give me a moment. This is the code that does that same thing. I'm going to show it to you inside this little utility online called JS Fiddle. Down here is that program written. Now, before I even run it, I'm going to show you these two things side by side. See if I can make this side by side happen. So here's the example program. And here's an actual program that does this exact same thing written in JavaScript. Now, we don't need a start program statement. JavaScript is one of these nice, easy to use languages that just goes to the first instruction at the top of the file and starts running it. Here you can see that we've created a couple variables. That corresponds to set secret number to 5, set user guess to 0. This is how we do that. It's how we work with variables in this particular language called JavaScript. And now we're going to build a subprogram. In JavaScript, subprograms are called functions. In many computer languages, they're called functions. Not always. But here, subprograms, they happen to be called functions. So we have a function called getUserGuess. These brackets right here, you can see they're underlined, which is a nice handy little feature of this little site. Everything in between these brackets is the set of instructions inside the subprogram. Again, we call subprograms functions in JavaScript. So the instructions inside the function are inside the curly brackets. This is an example of how friendly a computer programming language can be, where it's very obvious to you as the writer of the code or anyone else coming along after and reading it to see, okay, they made a function. What are the instructions inside it? Well, they're separated out by these curly brackets. So what does it do? Well, it creates a variable called guess, and it's going to give it a value, but we don't get the value until we've done this. We've prompted someone and said, guess a number between 1 and 10. If they don't enter a number, then it defaults to 0. And when they do enter a number, now this variable called guess, we give it the value they entered. And this part is really cool. This return thing is really neat. I said earlier that a subprogram can be called by the rest of the program. We call it the main program. The main program is everything outside of the function. When you call on a function or a subprogram to do its job, there's two things that are fun to think about. One is, does that subprogram need any data in order to do its work? In this case, it doesn't. Another thing to think about is, when the subprogram is done doing its work, do I as the part of the program that asks the subprogram to do its job, do I need the subprogram to give me anything? It did some work. Does it need to give me anything? And I want to make a point here. Let's go back all the way to the beginning of this little workshop here. I said that the purpose of a computer is to take in data, process the data in some way, and send data on. You can think of subprograms the same way. They can take in data. Sometimes they need it, sometimes they don't. They can process data, work with it in some way, and they can send data on. In this case, our subprogram is going to send back the variable guess. They're going to send back, what did the person enter? That means whenever we want to get a guess from someone, all we have to do is run this subprogram. They'll enter in a number, and the other parts of the program now have access to the number the person entered. You can see that here where we have the while section. The while section has a curly bracket and then another curly bracket. That corresponds to the fact that graphically over here, we said the while is right here. Everything inside it is inside the while, and here's an end while. The curly brackets are how you accomplish that in JavaScript. As long as the variable called user guess, this symbol means not equal. As long as user guess is not equal to secret number, we will keep on doing everything in between the open and closing curly brackets. What do? Well, it says over here, call get user guess. Look, we call get user guess. Remember, when we call this function, when we call this subprogram, the way we built it, it's going to give us something back. It's going to give us back whatever the person entered. We take what they give us, what this subprogram gives us back, and we use it to change the value of the user guess variable. This is why it's so important to make use of variables. We want to be able to work with data that can change as the computer program runs. So we've done that. We've gotten an actual user guess, and we've taken whatever they guessed and given it as the value to this variable called user guess. And now we're going to check if user guess is equal to secret number. And it's written like that. If, and then inside these parentheses, we check whether or not these two things are equal. Is user guess equal to secret number? If so, we do everything inside these curly brackets or braces. We'll just send up an alert that says, hey, congratulations. If not, well, here's the if not. It's called an else. We do everything inside these curly brackets, braces. We send an alert that says, wrong guess, try again. And then suddenly the person is going to guess the right number. User guess is actually going to be equal to secret number, and we will stop doing everything inside the while block. Only then will the program be allowed to move on to the next instruction, which is we put an alert that says, thank you for playing. I put that in there just to be nice. So let's run this. And it says, guess number between 1 and 10. Let's see, is it 3? Wrong guess, try again. Oh, man, great. All right, I'll try again. All right, let me try a 7. Wrong guess, try again. So let's look what's happening. We've gotten down in our program to this point right here where we're running this subprogram called get user guess over and over again. And what it does is over and over again, it puts up a prompt that says guess a number. And then it compares whether what we guessed is equal to secret number. It isn't. So remember the control and branching, every time we check if they're equal and they're not, then we don't do what's inside this little set of curly braces. We do what's inside this set of curly braces. You can see it. Wrong guess. Try again. Well, let's do it the right way. And let's guess 5, because I happen to know that's the secret number. And now, when we did this comparison right here, when we checked for equality, they were equal. So we suddenly do this other branch of code. This branch tells us to send up an alert that says, congratulations, you guessed the right number. And it did. Now, when I click OK here, the computer program is going to once again check whether or not user guess is not equal to secret number. They are going to be equal, so we are no longer going to be doing what's inside these curly braces. We're going to jump outside the curly braces and move on, and we'll do this alert. Click OK. It does the alert. So again, I know it's a really simple program, but it does make use of all of these elements of a computer program. It illustrates the use of variables, why you might even want to care about keeping track of data that can change. It shows you how to build a subprogram, an action you want to repeat over and over again. And it shows you the controlling branching statements. What do we do if, and what do we do else? These are different branches. One thing I want to show you here that's kind of cool is, let's say we use this get user guess function over and over again throughout our program, and we wanted to change it where they could guess between 1 and 12. That's all it takes. I know that seems pretty simple, almost stupid and foolish, but if we were using this function 50 times throughout a huge giant program, and we suddenly changed the way the game works and allowed people to guess between 1 and 12, I certainly wouldn't want to be the guy or girl that had to go through and find all 50 places that we were asking for guesses and change every single one of them. And because I have a subprogram, I don't. I can change it in one place, and now that change gets reflected everywhere in the program that uses this subprogram. All right. A lot of stuff there. Let me stop sharing for a second. Okay, so how are we doing on? Oh, good. We've got some time here for. Oh yeah, stick around here because we've got some really cool stuff to go over. Okay. I want to see if there's any questions. I have not been able to monitor chat at all. Regina, are there any cool questions in chat?
Not yet, but let us know in the chat if you guys have any questions.
Yeah, pop stuff in. We've got a little bit of extra time here for Q&A. I would be glad to answer anything about what we covered or technology in general. I'm a wide open book. All right, Regina, keep watching chat. Okay, and if anything pops in, I want to know about it. Okay. Oh, Auntie Destiny asks, is Java still in use? Yes, tremendously so. Java is very well maintained, constantly gets updates to the language itself, and is used for lots and lots of like what we call line of business computer programs. What I mean by line of business is, let's say you have, in the enterprise, in big corporations and businesses, you have lots of different types of needs. I mentioned some of them earlier, things like marketing and sales and accounting and inventory and people management, all this stuff. Programs that manage that for large organizations, programs that manage those types of things, they call them line of business applications. Very often they involve public facing websites for customers. They involve internal facing websites for employees. They involve huge databases that store all kinds of data about the historical operation of the company. They can encompass a lot of things. Java is used for building those kind of applications a lot. It's very popular. That was a great question. So Java is absolutely still in use. Okay. Lisa says, very clear and succinct. Thank you. And one quick question. In the Tech Academy, do you use an, she says IDE, that's the perfect term. It's called an integrated development environment, right? Or a sandbox. Great question. Let me clarify. What I'm using right here, this JS Fiddle, that's what's called a sandbox. Okay. Now, what that means is that it's a website that provides you an isolated place where you can write some code and just see what it does. You can't install a full-blown computer program into here and have it operate as a regular program would. It's a isolated, they call it a sandbox, so you can play around in there, and then as soon as you're done playing, you smooth it all out, the sand's all smooth, and everything's gone. Okay? What she's talking about with this integrated development environment, this is fun, programs that help you create programs. I'm going to show you one right now. This is a program called VS Code. This is an integrated development environment. By integrated, we mean it integrates several different types of tools you might need as a programmer to do your job. You have, for example, a folder and file structure here to see all the folders and files in the program you're making. You have a text editor here where you can look at the different files that you're making and you can write code. You have tools in here to run your computer program and to do what's called debugging. Debugging lets you stop your computer program midstream. Right while it's running, you can stop it and look step by step what the program is doing. Really powerful, right? It has tools for keeping track of the different versions of your computer code, like a bunch of tools all rolled up into one program. It's called an integrated development environment. So your question was, at the Tech Academy, do you use an integrated development environment? Absolutely. In fact, we've got a course specifically on how to make the best use of integrated development environments because they're such a powerful, fundamental tool for software developers. That's a great question. R. Anderson has a lovely nerdy question on this. What about a double loop to generate or fill a 4x4 matrix? You can absolutely build those things, right? What he's talking about is building loops, like repeating cycles of action where you go through a process, say 2 times, but each of those 2 times, it makes you go through another process 2 times. So you're actually going through 4 different cycles. Cool question, nerdy thing. You can absolutely build those in almost any modern language. And there's times where that's actually a really vital thing to do. I don't have time right now to build it out in code, but it's a great one. And I think that'd be a fun one if we had one of our coding classes that had a little bit of free time at the end to kind of build out. Good. Any other questions? Okay, cool. So let's talk about the school, who we are, and whether or not this is actually the right fit for you. And I want to stress something. We're looking for people for whom we are the right fit. When we go through this material, if it's not the right fit for you, completely understand. Please keep attending these classes, gain as much valuable data as you can about them, tell your friends. But if what we go over here shows you that we might be the right fit for you, please apply. So, first of all, stick around. We have a free gift coming up in a few minutes. I mentioned before we have a lot of different certifications or a lot of different boot camps. We have 12 coding boot camps. Let me switch here so that you can see those. I apologize. There we go. So we have 12 different coding boot camps, right? You can see some of the subjects right here. Some of them should be familiar because we went over some of these languages. You can see C# in there. You can see Java. You can see JavaScript. You can see Python. We do, in fact, have full-blown boot camps on those really popular languages because they are in demand in the tech industry. But we cover a whole bunch of other technology subjects, including artificial intelligence, website development, cybersecurity, design and user experience, data science, video game development, mobile app development, and more. So if there's an area of technology that you feel is better suited to you, we've got it covered. In fact, we have more certification programs than any other coding bootcamp on earth. And these aren't flash in the pan, develop them real quick. Every single one of these was put together at great expensive time and effort and money and industry expertise to be very comprehensive. So how are these boot camps delivered? How would we describe them? Well, a key thing is that they are self-paced. And I want to just pause for a moment and stress something about that. Most of us, in terms of learning as a formal activity, we're used to a very linear approach. Class starts on a certain day. College classes start in a certain time period, right? Everybody arrives at the same time, and you go through the material or whatever at the same pace as everyone else. I understand why it was built that way, but it's inevitable that some students are going to be frustrated. Either they're really bright and they grasp everything really quickly and they're bored, or there's an area they're having a challenge with, but the class has already moved on. It was vital to us when we designed these programs 10 years ago that we never leave anyone behind if they're working their tail off and really trying to get through this stuff. So our programs are self-paced. They have instructor support, which is great. So before, like say in a college environment, you've got to, like if the instructor has moved everybody else along, they're not capable of going back and helping you if you're 2 or 3 or 5 days behind everybody. Here, we can support you whatever pace you go through. The programs are really flexible. You can set your own schedule. You can enroll 365 days a year. We want to have as low friction approach as possible so that when your life is set up to start, you can start right away. The content is extremely well-rounded. Like, we don't just teach you one narrow path through. We want to teach you all the fundamentals and go in depth so that when you hit the ground on the job, if you're working with something that's similar to but not identical to what you learned, you're able to figure out how that new technology works. Boot camps are really affordable. They're priced under the national average. We talked about them before. And one really cool thing is that our programs all include job placement training and assistance. This is a differentiator. It's one thing to try to help people get a job in tech, which we do and we're very good at it. But we found that the technology of learning to code is different from the technology of getting a job in tech. They are two different bodies of knowledge. And so we found it was necessary to have a course on how to get hired in tech. And you do that training before you work with our job placement directors so you actually know what to do. And it goes really well. And most importantly, our courses are designed for absolute beginners. No technology knowledge or prior coding experience or anything is required. You don't have to be a nerd who's lived with this stuff their whole life to get through our boot camps. In fact, they're designed so that if all you can do is read and write and do basic math, you can get through them. Okay. I want to address one real quick question because it relates to what we're doing. Lisa's asking, would you be able to see a few words about your instructors and your methodology? Okay, good. So this is great. I learned this a long time ago, and it was a very painful lesson to learn. Being a very talented programmer does not mean you're a talented instructor. And I've learned that, like I said, painful lessons in that regard. When we select our instructors, one, they have to have graduated from one of our boot camps. Our methodology is unique enough that we found that if we have someone that hasn't gone through the boot camps, they're not going to help guide other people through the boot camps. Secondly, we look for friendliness and willingness to help, willingness to understand what it's like to be a beginner and help people through that journey when we choose instructors. So people love our instructors. Secondly, methodology, I think we've covered a lot of that. That was a really good question, Lisa. If at the end of it you have more questions, just let us know. You can email them in. All right, so this industry we're in, the boot camp industry, is on the one hand really young. The first boot camps formed in the summer of 2012 in San Francisco. That's really honestly not that long ago. But for a young industry, it's got a surprising level of maturity, which is really cool. There's hundreds and hundreds of boot camps around the country, many more around the world. And there's a whole support structure for that industry where boot camps are ranked, and they have been for years. Every year, consistently, we land on every major best coding boot camp list, and we're super proud of that. These are some of the awards we've got. This is what our students and graduates have to say about us. Each one of these places is a review site that is, in fact, objective. As the provider that's being reviewed, you're not allowed to change anything about these reviews. So we're super happy to have an average 4.8 star review rating on all the major bootcamp review websites. So enough about us. I just want to talk about the general concept of why would you even work in tech in the first place? Here's some things that are pretty cool about it, and then we'll go to some things that are a bit of a challenge and what we've done about it. One is that technology as an industry in general has a really good work-life balance. Very rarely do you have jobs where you're consistently asked to work more than 40 hours a week. There's a lot of opportunity for remote work, which is fantastic, right? And it's a super creative industry. I talked earlier about the dynamic, like collaborative, communicative nature of designing software. And I talked about that border between the logical computer, this machine, and human beings that are meant to use these tools. Because of that situation, making good software is a creative activity. We often say that there's 100 different ways to solve a specific engineering problem in coding. You can solve it 100 different ways. Why do you make the choices you do? That you get to be creative in this. You get to solve really unique problems sometimes. It's a blast, right? And that gives you a lot of personal pride in your work, especially if you work on something and it ends up being in the hands of the end user and it helps them. You can be very proud of that. And we need to talk about the money part of it. The tech industry is a very stable industry. It just keeps growing and growing and growing. I did a presentation a few weeks ago about this in detail, but I'll just summarize. Every 5 years, the Bureau of Labor and Statistics for America does basically a future prediction for all different sectors of the economy. How many jobs are going to be needed in the next 1 year, 5 years, 10 years? Back when we started in 2013, the tech industry was projected to need 1.4 million employees over the next 10 years. Well, flash forward to 2018, and the projection was, guess what? Over the next 10 years, we're going to need 1.35 million more workers. And then back in 2023, just released this data. It's 1.4 million. Like, we are so behind. Even with colleges and boot camps, as productive as they are, we cannot keep up with the demand, which is really cool. Also, tech pays really well. Our school, for example, there's lots of schools out there. Our school, our graduates on average earn $60,000 a year in their first role. I don't know of any places you can go in terms of industries, work really hard for 3, 4, 5 months, and make $30 an hour when you get out. There's very few things like that. And if you're dedicating yourself and you're continually learning, working hard on the job, there's regular increases in pay. Within a few years, you can make over $100,000. Many engineers make $150,000 to $350,000. There's a lot out there, which is really cool. All right, now, there are barriers to entry. Let's talk specifically about the route into tech that is the boot camp. We happen to be experts in boot camps. The fact is that boot camp costs thousands of dollars. I don't know any boot camps out there that are super, 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 super cheap. And if they are, you're not getting a great product. And you got to guide yourself through all of it, right? Boot camps cost thousands of dollars. Now, again, we are priced under the national average, but there's other things. First of all, we have multiple financing options, a lot of different ways you can go. We do have upfront discounts. We have monthly payment options. But the ultimate thing is this. Getting through a Tech Academy boot camp is truly an investment in yourself. You're giving yourself the know-how to enter a very valuable industry as a valued contributor and have a long-term career and make a really good living right out of the gate. So yes, it costs a bit. Our most popular boot camp costs 10 G's. Turn around 4 or 5 months later, get out on the job market, and it comes back to you real fast. It takes time. It's an investment of time, of effort, of energy to get through. You've got a lot to learn. Now, we've made it as easy as possible if you apply yourself to actually learn the material and actually be able to apply it on the job, and most importantly, to feel confident when you graduate that you can, in fact, do the job. I haven't even talked about our live projects. When you actually work as part of a real software development team, they're awesome. But it does take time. The approach that some boot camps have to this is they only run cohorts. They'll gather together 10 or 20 or 30 students. They all start on the same day. And for the next 4 or 5 months, 5 days a week, they're all moving at the same pace. We don't do that. First of all, you don't even have to come into the campus. Our programs can all be done online. But more importantly, you can choose your study schedule. Yes, you need to put a certain amount of time in, or you're just not going to get through it in any reasonable amount of time. But you choose what that schedule is. So you got flexibility to work around what your life is. You can, in fact, do part-time study. Yes, it's great if you can set up your life to do this full-time, 40 hours a week. That'd be awesome. Our students that do that, they love it. But it's equally as effective if you have a part-time study schedule, which means you can study concurrent to holding a job or going to school, which is pretty cool. And finally, you do have to have some technical interest or ability. This is an important one. If you do have technical interest or ability and you've started to look out there, you may have found that some of the technology education materials that you're encountering are frankly just too hard. It's like they go right over your head. The primary reason this happens, and what we solve, is that most technology education assume too much prior knowledge on the part of the student. It's so easy to forget what it was like to be new to a subject that even when they're trying to produce quote unquote introductory material, they miss super important fundamentals. Now, I'm not saying we're perfect at this, but we know how important it is. And every single time we write curriculum and revise it, we are constantly finding how do we make this more accessible to people with less experience so that anybody can get through the program, which means you don't have to be a nerd going into this. It helps because then you get all my stupid jokes that I make during the curriculum, but you don't have to be a nerd, right? And it also means you don't need any technology background in order to enroll, which is pretty cool. So I just have a couple of questions for you. Like all around this concept of is it time for a change for you? Are you, for example, working a dead end job? It's not that you hate it, but the career progression just isn't there. You look ahead at what that ladder looks like, and the ladder just stops a couple rungs above you. Or are you unemployed? Are you really interested in having a career where it is real for you to work from home, for example? Do you want more time with your loved ones? You're working 60, 70 hours a week, and you're like, man, if I could work, you know, less than that and make more, spend more time with the people I care about. So, is it time for a career change? If it is, and anything here tonight has resonated with you, then we can help. We are that bridge between you and a successful career in technology. As I said earlier, most of our graduates make $30 an hour in their first job, which is fantastic, right? Over the years, we have become career change experts. A lot of the people that come through the program are already doing something else in a professional capacity. And for whatever reason, they want to shift. Most people, when they accomplish that shift, are able to do it without taking a pay cut, which is really awesome. Very often people are making $40,000 or $50,000 a year in one career, and they come over and they graduate, and now they have technology knowledge and they have that working experience. They're more valuable on the market, and they end up getting $60,000, $70,000 a year jobs, which is great. At this point, we have a decade of experience in helping people break into tech. We've got over 1,000 graduates who are working in tech. And where are they working? Well, everywhere. They from small businesses that need, in-house programmers to, technology positions at the giants like Nike, Facebook, Disney, Uber, Epic Games. We have people placed everywhere. So as a reminder, we offer open enrollment. You can start anytime. And again, if this resonates with you, I encourage you to enroll now. How do you do it? First of all, stick around. Your free gift is coming. But to apply to see whether or not you can take advantage of this, go to this link. Regina is going to put it in chat. There it is, right? When you click on it, this is a super simple form, 3 fields or whatever. Just fill that in. And after the form is a series of steps that tell you everything about the Tech Academy. We want you to make an informed decision. So you have videos, articles. There's an optional step in there to book a call with our admissions folks. I'd ask that you sign up on the form, and then as soon as we want the event, complete those steps. You'll enjoy them. We put a lot of work into giving you as much information as possible so you can figure out whether or not this is the right fit for you. So I'm going to pause for a minute or two for anybody who wants to click on the link and fill out that form. And honestly, I need a sip of water. Jeremy says he's become a nerd through this. Yes. No, Lisa, I am not going to give out a free gift that is a Baby Sheldon nerd pocket protector. Although I absolutely love that. That's fantastic. Oh, let me explain this thing at the bottom of the side that says login credentials. If you've already gotten an account at our website, learncodinganywhere.com, when you go to this page, it will actually notice you and it'll pop up a login screen. Just use the system at the bottom with your email address and that password, and it'll pop you right in. Baby Sheldon nerd pocket protector. I wish I had Photoshop skills. Lisa asks, do we teach C? No, we don't teach C. And the reason is I don't hate myself. C is a good, decent language if you really want to go about making software through the most cumbersome process possible. There's a reason C# is popular and C isn't. There's a reason Java is popular and C isn't. It's because it's so much easier and faster to make software in those modern languages than it is in C. C does have its place. I'm going to knock on it a little bit. But as long as you're going to learn programming, learn a language that the industry actually wants. There's not very many C jobs out there. Lisa. She says, good answer. I'm strangely charmed by C. I'm developing resilience by ignoring the computer's chiding. C is a very snarky language because if you don't get everything perfect, it will let you know you didn't get it perfect. I love that. Okay, good. All right, so let's talk about this free gift and all that kind of stuff. First of all, we have a referral program that I really encourage you to take advantage of. If anything about this is like resonated with you, and you think that someone else should hear about us, we'd like you to connect us to them. Our graduates love us, and because of that, referrals are one of the top enrollment sources for us. And so for years, we've offered a 5% commission payment for all enrollments that come for a referral. We will pay you 5%. Period. End of story. If you are who got connected us to them, when they sign up, we send you a check for 5% of it, right? So how do you take advantage of this? Well, in a minute, I'm going to have you send in an email if you want to take advantage of our free gift. In that email, if you'll include the name and contact info of your referrals, we will track that. And if they end up going through our process and signing up, we'll send you a check. Lisa, you can't refer yourself. That was genius. Okay, so we're getting to this point about a free gift. I want to explain. The Tech Academy has 7 publications that we've written over the years, including 3 Learn Coding Basics in Hours books. You can see those at the bottom of the screen. We have a coding book for kids and young adults, which is awesome. If you have a middle school age kid or whatever, even younger, get that book. It'll change their lives. We have a technology basics dictionary because having clear, simple definitions for all these technology terms is important to everyone. We have a project management handbook to explain how software is made. And we have You Are Not Stupid. And I want to talk about You Are Not Stupid for a second. This is basically a written version of probably the most important course we have on all of our boot camps. It's called the Computer Basics course. It's the first course everyone does. And it removes all mystery from technology, computers, and everything related to this industry so that when you start your formal learning to code process, you're doing so with an unbelievably firm foundation. So we took everything in the Computer Basics course, added even more, including a history of technology, showing how we arrived at the current state of the industry today, and put it all into You Are Not Stupid. This book is for anyone, and we're super proud of it. So here's the free gift. I talked about how software is a social group activity. It's not just one guy or girl in the basement eating Cheetos and drinking Jolt Cola. It's a phenomenally collaborative activity. Well, how do you collaborate? This book shows how that process works in really clear, easy to understand terms. So if you are in the US, sorry, it's US only, we can send you your own copy of this book. It's an actual physical book. All we need is your full name and your actual mailing address. PO boxes are fine, whatever, we can send it there. So just send in your name and your email address to books@learncodinganywhere.com. Give us that info. We'll send you out a copy of this book. We send them out every week, and we love it. So I'll wait 1 minute for people to fill that out, that email, to send an email, and then we'll move on. Lisa, I hope I'm not the first person to tell you this. You are turning into a bona fide nerd, and I absolutely love it. I wish y'all could see her chat. She's like flat out awesome programming nerd. It's great. All right. So if you want to be connected up to us, we have all of our links in one location at our link tree. Regina just popped that in the chat. Grab that link tree. You'll see in there links to our free educational YouTube video playlist. This video will go up in there in about a day or two. All of our free training videos go on there. You'll see links to our books, our dictionary. Most importantly, you'll see links to our upcoming classes, our upcoming meetups, and you'll see all of our social media accounts. So if you enjoyed this and you want to stay connected to us, follow us on social media. And I invite you to invite your friends to future classes. We do these twice a week. You can see the schedule, like I said, at that link. And here's an opportunity. This truly is a good book. You Are Not Stupid. If you'd like your own copy of this, it's really hefty, right? We can't just send these out willy-nilly, but you have an opportunity to win one. If you will do two things, you'll be entered to win a copy of You Are Not Stupid. If you can share the link to our next event on your social media and tag us on that platform, we keep track of that, and we'll take everybody who does that in a given week. We'll pick one of them at random, and we'll send them out a copy of You Are Not Stupid. So again, share the link to our next event. They're all there at the link tree. And tag the school, tag the Tech Academy, and we'll enter you in to win your own copy of You Are Not Stupid. And then we like to announce those at these various events. All right, so thank you for attending. I super appreciate it. If you filled out the form, make sure you continue on through and do the steps afterwards. If you haven't filled out the form and you are actually interested in looking at our boot camps, go ahead and fill it out. I hope to see you at the next event. We're going to do a coding one in a couple of days. And thank you all so much. Lisa, I super love your feedback. And you will make a phenomenal technologist. The fact that you have a teaching career is a tremendous asset in technology. Thanks, all. All right, we're going to wrap it up. Thank you guys so much. Super appreciate it. And we'll see you next time.